if you have something, I'd like you to end up with a cylinder that is closer to something like this, as opposed to ending up with something that looks like that. Now, here's why, and I'll explain even more detail on Wednesday. But basically, when you have a tall, skinny cylinder like this, the speed at which the soft edge gradates is determined by the radius of the form. So if you have a smaller form, like a narrower cylinder, you'll have a very, very fast turning of the form. And that will be difficult for you to render. If you have a squatter form like this, you'll have a broader area across which it blends, and it will tend to be easier for you to create realistic effects with a squat form. Okay? So it's up to you, but that's just my advice to you. Now, I'm assuming, again, I'm sketching this for speed reasons. I'm assuming all of you guys could do this perfectly mechanically as well. You know, using measuring points, vanishing points, rulers, the whole 9 yards. Now, if you did this that way, what you would end up with is something like this. You would have a measuring line, okay, and you would have a points on here, like this line here would represent this line seen without foreshortening. You understand where we're going so far with this? Okay. Now, ignore the rest of the box for a second, and let's just concentrate on the bottom square. If I have this bottom square, we can already do this. And while I really think you guys probably are in pretty good shape in terms of drawing your ellipses, but let's say that you are feeling a lack of confidence, which for a mechanical, you want to be more correct. Here's how you get it exactly correct. Okay, get an exactly correct ellipse mechanically. And everyone stop taking notes for about the next minute or two, and watch me go through the process, and then I'll explain it and let you take the notes. And this will seem so simple to you, you'll wonder why you didn't think of it before. Okay? Watch. You drop a measuring line there, you drop a measuring line here. Oh wait, that's number 3. All right? You take your compass and you draw a circle. You mark where it crosses the diagonal lines. You go up. You use the measuring point to transfer it in, and then you use the vanishing point to transfer it across, and you hit 2 additional points on the ellipse. You could also, at that point, either use the vanishing point to go this way and hit 2 more points, or you could do the same thing here, and you would get the exact same result. But you end up with 8 points. See how stupid that is and how obvious it seems? Okay. I love it when I make people laugh out loud in this class. It's like, talk about nerdy, which is good. So take the notes you need to take on it. That's the mechanical trick you need to know to make a perfect cylinder out of a box. Yes?
Can you, do it for real?
Can I do it for real?
Yeah, with, everything, with all the tools.
Okay, I will try. I won't try, I will do. There is no try.
Yeah.
There is only do or not do. You guys, I'm going to do it on the back of one of these. I think that'll work okay. Okay, and actually I'm going to try and do it kind of fast because I'm a little worried about time. guys, I'm drawing the box quickly without talking about it, because I'm assuming you guys are okay with the whole box part. What?
I don't know where I put this place in my chemical short term.
Oh,
I know.
oh.
It's so
What?
I miss the little, like, I miss being able to do that little, like, thing, because I haven't been able to do mechanical because they don't allow them.
Okay, you guys, so here's the mechanical version. Basically, I'm finding this point and or that point, it doesn't really matter. Okay, I have diagonals previously drawn across here and here. So watch carefully. I come straight up, I hit that point, I use the measuring point to transfer the measurement to the side of the square right there. And then I draw across and mark where it hits the two diagonals. Now, I think it's actually easier to show you on the other one. Because on the other one, you know, I'm taking a lot of the lines out. You know, I'm only sketching in the essential stuff. But essentially, what you're trying to do is, you're just trying to get this measurement onto the square. And once you do that, especially if you guys keep in mind the stuff about that you already know about drawing the major and minor and bisecting and going through certain points and, you know, and the symmetry, if you keep in mind all that stuff and you have 8 points to draw with, it's pretty hard to, I mean, can you guys already see that ellipse? You know, it's pretty hard. I mean, now you may still have trouble drawing it, or you may want to use an ellipse template or something like that, but this is actually how you do it. Okay, now, let's imagine, actually, did that help? Are you good?
Yeah.
Okay, now, so let's imagine I did this really carefully, and I ended up with that, okay? Now, let's take a look at how would you do this on the top. Everyone watch how quick this is going to happen. You found these points. Just bring them up and do the exact same thing, and you'll end up with this. Hey look, a thin ellipse, a fat ellipse. Just the way it's supposed to happen. And then there's only 2 more things you need to do. Watch. You're done. Yeah, Alicia.
My one question is, how, this is probably a stupid question, how did you find the non-foreshortened side of the box?
This side?
No,
This side?
well, the other side.
This side?
Yeah, yes, that,
Um,
and then.
Okay, what you will have to do is, remember when you're drawing a cube, how you start off with a square?
Mhm.
You'll have to start off with a square.
Okay,
And so do all that exactly the same way. And I I just drew something that was close to a square and said it was a square. So you have to start off with the square on the ground plane, and then project it up. The only thing I would do is I would not make it as tall as it should be. So make a big square